Assalamu alaikum and welcome. In today's episode, we will talk about electric field. So what is electric field? Electric field lines are just the graphical and visual representation. In my previous video, I discussed about charge particles. And we discussed there are two types of charge particles, positive and negative. Like charges or like particles repel each other, and unlike charges and unlike particles attract each other. So when positive and positive come close to each other, they are going to repel. Similarly, negative charges will show the same behavior. While if two objects are oppositely charged, they are going to attract each other. So there is a force of attraction and repulsion. The electric field just represents that force of attraction. In today's video, we will learn about how to represent electric field lines, how to draw them, and what do they represent. So let's get started. For an isolated charge, like a positive charge or a negative charge, the electric field is represented as follows. Let's just say I have two charge particles, one is positive and another is negative. In case of positive charge, the radial lines will be pointing outward. The arrows are representing the direction of the electric field line. Now, if you look at the diagram, what you will observe is that the gap between the electric field lines is narrow, close to the charge. But as you move away from it, the gap between them starts to become wider and wider. What it actually represents is that the force of attraction or repulsion will be stronger close to the charge, and as the distance from the charge particle will increase, that force will start to get weaker and weaker, which is represented here by the gap between the electric field lines. For a negatively charged particle, the electric field lines will be represented in the same fashion, radial lines. That's how you will draw. Although the one difference between the positive and the negative charge particle's electric field line is the direction of the arrows. In this case, the direction of the arrow will be towards the negative charge. Now I will draw the electric field line pattern for like charges and unlike charges. So let's get started. Now, as I discussed before, that unlike charges attract each other and like charges repel each other. So if two oppositely charged particles are placed close to each other, how the electric field pattern is going to look like. In this case, the electric field lines will be originating from the positive and they will be ending up at negative. You will notice that as you move away from the charge, the gap between the electric field lines starts to become wider and wider, which, by the way, is the same reason as I discussed before. So that's how you can draw the electric field lines. Now, one very important point that you have to remember here, that the electric field lines never overlap each other. Each electric field line will have its own separate path. None of the lines are intersecting or overlapping each other at any point. And now we will draw the electric field lines pattern for like charges. So let's just say I have two negatively charged particles placed close to each other. In that situation, as I discussed before, that the like charges repel each other. So there will be a repulsive force. Now the electric field lines pattern will be something like this.
You have to excuse me for my drawing, it's not that perfect, but I'm trying my best here.
So as you can see here, the electric field lines are coming and ending up towards the negatively charged particle, but in this region, none of the electric field lines are coming close to each other because there is a repulsive force between the charged particles. Similarly, if you have to draw for a positively charged particles to like positively charged particles, the pattern will remain same. The only difference will be that instead of the arrows pointing towards the negatively charged particle, the arrows will be pointing away from the positively charged. And finally, let's draw the electric field pattern for two uniformly charged rods. Let's just say I have two metallic plates or two electrodes, all right, and one of them is positively charged and another one is negatively charged. Both of them are made up of same material, have same cross-sectional area, same dimensions, placed close to each other. Then in that case, what will be the pattern of electric field lines? Let's take a look. In this situation, the electric field lines will start from positive and end up at negative. Now, as you can see here, that the gap between the electric field lines is almost uniform per se, and that creates a uniform electric field. As the arrow indicates, the electric field starting from positive and ending up at negative. That's it for today. I hope you understood. Stay tuned for more episodes.